Alright, these are our notes for section 4.1 on classifying triangles, and we're going to do three things in this video. Everything in this chapter in chapter 4 is about triangles, so today we're going to learn how to classify triangles in two different ways, by their sides and by their angles. We're also going to learn how to name a triangle, and then we're going to solve some problems using the side length classifications of a triangle. We'll use the angles on a different day, but today, these examples, we're just going to focus on using the side length. Alright, so first thing, there's two different ways to classify triangles. We can classify them by their side length, and there are three different classifications. Your first one is scalene, which means all sides are different lengths. Okay, so each side, three sides to a triangle, each one of the sides would have a different measure. It would be a different length. Isosceles means two sides are the same. And we could say congruent or equal. All of those mean that the two sides would be the same. Okay? So two of your three sides would have the same measure. They could both be whatever number they needed, but the third side would be something different. Equilateral means all sides are the same length. Okay, and it kind of gives you a hint in the name. Equa sounds a lot like equal, and lateral deals with distance, so it means that all sides are the same distance. They all would have the same measure. They'd all be congruent. Okay, and those are the three ways to classify by side length. Now you can also classify triangles by their angle measures, and there's four ways to do that. First way is acute, and acute means that all three angles in your triangle are acute. And remember, acute means that they're less than 90. So every angle in the triangle would be less than 90 degrees. That's what an acute triangle is. Obtuse means one of your three angles is obtuse. And it's only one. And we'll talk about this, I can go ahead and tell you. There are 180 degrees in a triangle, and if you have an obtuse angle, there's only one obtuse angle in a triangle. You can't have more than one obtuse angle, because anything more than 90, if I add anything more than 90 twice, then I get something over 180. And we'll talk about that more in a different section, but I need you to realize today that the classification for an obtuse triangle means that just one of the angles is obtuse. The third way is a right triangle, which means an angle is a right angle. Remember, that means 90 degrees. Okay? And for the same reason that you can only have one obtuse angle in a triangle, you can only have one right angle in a triangle. And that'll be something we talk about in a different section again. But you can only have one. So when you're looking for the classification, you want to see that there's only one right angle in the triangle. And the last one is equiangular, which would mean all your angles are congruent. And I'm going to go ahead and tell you, if it's equiangular, all the angles are 60 degrees. Okay, that's important. And that's for that reason that there's 180 degrees in the triangle. If I have three angles that are exactly the same out of 180 degrees, that means each one would have to be 60. So, if you have a triangle where all three angles are 60 or all three angles are marked congruent, then it's an equiangular triangle. Now, there's one other thing I want you to remember. Equiangular and equilateral always go together. If I have an equiangular triangle, then I automatically have an equilateral triangle. They have to go hand in hand. The other classifications don't. You can have a scalene paired up with one of the other three, or you can have an isosceles paired up with one of the other three classifications. They can mix and match, but equilateral, equiangular have to go together. Okay? Alright, so those are our ways to classify triangles. And again, when we get to the examples, we're going to use the side length classifications today. Alright, the second thing we're going to look at, we're going to name a triangle. Now, it's really easy to name a triangle. First thing you want to do is pick a vertex. which is one of the corners. Pick one of the corners. And then the second thing is you're going to go around the triangle. And you make sure that you hit all three vertices, all three corners. Okay, so I'm going to start with A. I'm going to work my way back around to A. So I would name this triangle triangle, and I can use that symbol. I start with A, and then I went to B, and I ended at C, and I ended back up at A. I don't list A a second time. Okay, I just use the three vertices. Now it doesn't matter which vertex you start at, and it doesn't matter which way you go. I went counterclockwise in the example here. You could have gone clockwise, which would have given us triangle ACB. That's also acceptable. Okay, it doesn't matter. Now there are 6 different names for the same triangle. And any of them are acceptable. So if I gave you a problem where I said, name this triangle and it had 3 vertices, any of the 6 names would be acceptable. And it just depends on which vertex you start at and whether you're going clockwise or counterclockwise. That gives you the 6 different names. So it's fine to have something different as long as you go all the way around the triangle and you use all 3 of the vertices, all 3 of the corners. Okay, so that's how we name a triangle. Now, you can put that triangle out in front. That's perfectly fine. I will warn you, as we get to different shapes, you can't put just the shape out in front. Triangles and circles are the only ones that you can do that for. So, you can put a triangle out in front of your names for this chapter, and any of the chapters where we talk about triangles, you can do that for all of them. But when we get onto different shapes, like squares and a rhombus, a parallelogram, we can't do that. So a triangle is the only one you can use that little symbol for. Alright, we're going to move on to the examples now. Before we get to the examples, there's a couple things we need to remember. First thing, you always want to draw a picture if they didn't give you one. Okay? It's going to most likely be in the directions to draw one, so it's again a good habit to get into to always draw a picture. Whether you need it or not, it's a good habit to get into so you can see what's going on. Once you've drawn the picture, then you need to label the picture. Also important, so you can see where pieces fall, whether pieces are congruent or how they make up the picture. That's important also. The third is to show work. Remember, you're going to write an equation and you're going to solve it. So make sure that you are showing work. And if you need to, go back and check. That's something that's not going to be expected, but it's a good idea to get, a good habit to get into. And the last one is to answer the question. We talked about this back in chapter 1 where we were finding pieces of a picture. Sometimes they'll just ask for the variable, and sometimes they'll ask for a part of the picture. Sometimes they'll ask for both. So you really need to read the question to make sure you're giving me the answer that the problem wants. Okay? So if you have to read it twice or have to circle what it's asking for, make sure you do that so that you can get the problem correct. If you solve it correctly, you just didn't give me the right answer, you're still going to miss points. So make sure that you answer the question for the problem. Alright, we've got our first example here. Our first example says find x and the measure of each side. So in this case, we're finding 4 different things. There's going to be 4 parts to our answer because we have the variable and then the 3 sides of the triangle. So there's 4 different answers to this problem. You need to make sure that you give me all of them. Okay, let's finish the question. It says find x and the measure of each side of equilateral triangle RST. So you're going to need to know your vocabulary today. Equilateral, again, means that all sides are the same length. And then it tells us that what each one of the sides measures. So we're going to start by drawing ourselves a picture of an equilateral triangle. Equilateral, all the sides are the same, so I'm going to draw a triangle like this. Put my R, S, and T wherever I would like. The reason it doesn't matter where they go is because all my sides are the same length. If I have sides that are different lengths, then it's important where I put my vertices. It's important to read the question, but if it's equilateral, it doesn't matter where they go. Okay, so I've drawn a picture. I've marked it equilateral by showing all sides are the same length. Now we're going to label the sides. RS is x plus 9, ST is 2x, and RT is 3x minus 9. Now we're going to solve this. To solve it, you need to set two things that are, remember we said congruent things are equal, so we can set them equal to each other. We're going to pick, we have three things here. We have three sides that are all the same length. Well, I'm just going to pick two of them and set them equal to each other. It does not matter which two, and that's important. People get hung up on that. Well, which two can I set equal? For an equilateral triangle, it doesn't matter. They're all going to be the same, so you can pick any two and set them equal. I'm going to pick 2x because it's the shortest expression, and then x plus 9 because I want to deal with a positive number. Now I could have used 3x minus 9 and I could have used either of the other two. It doesn't matter, but I just picked 2 and I set them equal. And now I'm going to solve this. So I subtract x. 2x minus x is just 1x equals, my x is canceled and I'm left with 9. So they're part of the answer to the problem, x equals 9. That's finding the x. Now I need to find the measure to each side, and this is a good way to check. Since it's equilateral, all of my sides should be the same measure. So I'm going to plug that in. First one, RS, it was x plus 9. My x was 9, I found that. So 9 plus 9 is 18. Second one, ST. The expression was 2 times x, and we found x to be 9. We get 18 also. I'm going to underline where the variable is so you can see that we're plugging in what we found the variable to be. Last one, RT. 3 times 9 minus 9. Well, that's the most complex of them. 3 times 9 is 27 minus 9 would be 18. So we did get 18 for all three sides. So then we know we did the problem correct, and that's a good way to check. We got each side to be the same length. If I didn't, I did something wrong, so I'd have to go back and solve it again. Alright, let's look at another example. It's going to be the same type of example, but it's going to be a different kind of triangle. So our second example here says find x and the measure of each side of isosceles, different vocabulary word this time, triangle JMN with JM congruent to MN. That means that these are our two congruent sides. Okay, so they need to be marked congruent in our picture. Remember, isosceles means that two of the sides are the same length. Well, two of them, it tells us which two are the same. So when we draw our picture, that needs to be shown in there. That's important that we get that correct. Alright, so let's draw ourselves a picture. Now you could draw a different picture. As long as it's isosceles, that's fine. Okay, I got my triangle, and I'm going to mark these sides congruent. Now, it's important where I put the vertices. If you notice, M is in common to both of them up here, JM and MN. That means it's going to be the vertex that the two sides share. So I'm going to put M at the top because that's where my two congruent sides meet. And then I'm going to put J and N on the other sides. That makes sense because JM here and MN are the same length. I've marked them congruent, and that makes sense with our directions. Now that we have a picture, we're going to go ahead and label it. JM is 2x minus 5, MN is 3x minus 9, and JN x minus 2. Okay? Now, when we give each side, remember, two of them should be the same, and the third side should be something different. We don't know if it's larger or smaller, we just know it's got to be something different. Alright, now to solve this one, again, if things are congruent, we can set them equal, and it tells us in this problem which two things are congruent. So for our equation, we're going to set those two things equal to each other. Alright, so we have 2x minus 5 equals 3x minus 9. Those are the two congruent sides. And now we're going to solve it. Subtract 2x from both sides. That gives us negative 5 equals 3x minus 2x is a positive x minus 9. Let's add 9 to both sides. Negative 5 plus 9 is 4. So x equals 4. And there's part of the answer. That's our variable. That's the first part. Now we got to find each side. So we're going to go back to each expression and we're going to plug in 4 for x. So 2, this is JM, 2 times 4, because that's what we got x to be, minus 5. Well, 2 times 4 is 8, minus 5 would be 3. Now, MN has to be the same because they're congruent. So if we've done the problem correct, we'll get the same answer. 3 times 4, that's where our variable goes, minus 9. Well, 3 times 4 is 12, and 12 minus 9 is 3. So far, so good. We've got the two congruent sides being the same measure. Now, we need to have the third side be something different. And it is 4, which is where our x is, minus 2, and 4 minus 2 is 2. So we've done the problem correct. We've got two congruent sides, and then our third side is something different. And we found all the pieces to what the directions asked us to do. Now, one thing I want to point out to you is that you need to pay attention to the problem. I'm going to sum up real quickly what you do for each type of triangle. If it's equilateral, you got to pick two sides and set them equal. And it doesn't matter what sides. You get to pick any two, okay, because they're all the same length. Isosceles is a little more specific. You need to pick the two congruent sides and set them equal. Okay? It has to be two specific sides, the two that are congruent. And then our third, scalene, we did not do an example of that, but for scaling, you're going to use perimeter. Now, perimeter is the sum of all the sides. So we would add all the sides up, and we set it equal to perimeter, which is a specific number. Okay? They will tell you on a scalene specifically what the perimeter is. They'll say the perimeter of this triangle is something, and you are given 3 expressions, and you need to solve for each side. Same idea, except this time we're adding all the sides up, and we set it equal to the perimeter. That's the only one that's different. Okay? Those are your notes on section 4.1 on classifying triangles.